More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Test. Oh, now it works. Nice. Yay! All right, perfect, guys. All right, that was a mission and a half, but that's all right. We're here. Thank you for sticking with us. Yeah, I don't even want to explain what happened there because I don't even have the answer. Luckily for us today, we have a super fun topic, so I can't wait to share it with you. And the reason, and I see you guys are already sharing with me, thank you so much, moderators who are there helping out with the comments. Love the question already that I believe I saw, which was, I had asked you silently, what brings you guys to today's topic, which is math and art. And I see you guys were sharing a little bit about what these two seemingly completely different topics or subjects that you might learn in school have in common. And the reason I so badly wanted to take care of this topic for today is because I love art. I actually, if you want to know something about me, your instructor, I wanted to be an artist my whole life. And weirdly enough, I ended up in the field of math. But I say weirdly enough because, again, these seem like two separate topics. But what I want to show you today and tomorrow and maybe even next week for so many other topics that we can discuss between the connection of math and art is that they actually have so much in common. And right before we get into our first activity today, I just want to share kind of my outlook on how these two are very similar. And so I just told you that I wanted to be an artist, honestly, my entire life up until the end of high school when I decided to study math. And the reason was I always had such wonderful experiences with artists. Artists, if you're an artist yourself, or if you know any artists yourself, or even if you just have a small interest in art, the beautiful thing about it is you become such a deep thinker and so you have such a different outlook on everything around you. And I absolutely adore that about artists and my artistic side of me. And honestly, growing up, my math teachers didn't really show that until I got to university. And so I'm so thankful that I studied math in university because that's when I started to experience professors that were so passionate about math that they actually saw math all around them. And I was convinced that they did. And they looked at the world so differently. And it really compared for me and showed the similarities between how artists see the world and how mathematicians see the world. And I love it. And the reason I love it is you see a tree, which I was just doing a few days ago in my backyard, and I was looking at the patterns that the branches form, and it seems so, what's the word? It seems like it's just very unique and that there's no pattern to it, but when you really observe it and you learn more about it, which artists and mathematicians will do all of that, you really see that there is a pattern. So let's start to look at it. And today, I really want to focus on how we can use our counting, the patterns and techniques that we know about counting, and see how we can form art from around that. Tomorrow, I want to look at 3D objects, and then we can look at 2D objects, architecture, countless other areas that we can look at. So let's start that today. So let me show you. I'm just going to show you my whiteboard in just a second. There we go. Having to restart the system means having to make sure everything is working again. All good. So you guys can continue to share with me what brings you here. And what I had said earlier when you guys couldn't hear me was I had named this math and art, but really what I want to show you is that there's a lot of art in math. And that's especially true for today's topic. So we're going to look at that. And my first question to you is just give me a number. And the first 3 numbers that I see, I will write down and I'll use them for our first activity. Any random number, and I'm going to ask you actually a single digit number for now. So share that with me. And while I see the first 3 numbers that pop up in my comments, I just want to clarify that today we're going to be looking at patterns in particular and how beautiful they can be and how math can really bring to life, I see my first number, mathematical patterns. So we're gonna have 8 as our first number. I see 5 and 7. There we go. I'm gonna take those 3 numbers first. And we're gonna do something with them in just a second. Hopefully you can see that's a 5. What we're going to form today, hopefully you have a sheet of paper ready with you. If not, you can watch, and then when you rewatch this lesson, you can form this. They're called spiralaterals. That's a funky word, right? I've never really heard of it before I actually did this activity. What do you think spiralaterals do? So I'm going to write out the word, and hopefully you see a familiar word in here. So spiralaterals. We're going to form something called spiralaterals. It's going to be based off of what we know about counting and eventually multiplication. So some of you who are joining me today who are from maybe lower elementary levels, this will be definitely suitable for you. What do you think? What word seems familiar when I say spiralaterals? What if I start to draw something like this over top my word? They make spiral art. I love it. Yes. So this, I know I'm going over my word, but hey, that's art, as a spiral, right? And we can see spirals all around us. If you think of even a snail's shell, we see spirals. Spirals, there we go, spiral. If you watched our lesson a few weeks ago on the golden ratio, you'll see the spiral formed out of that ratio. And so we're going to make some today. Oh, I see quadrilateral. Yeah, that's a good one. Yeah. And spirals. So we're going to make them today out of numbers. And I'm going to stick with these numbers. I'm just going to put them in order. So I'm going to write them as 5, 7, and 8. And we'll see how we can form some art pieces out of this. So the way that this is going to work is a spiralateral is formed from the repetition of a simple rule. In this case, we have 5, 7, and 8. Let me make sure that's in your view, just at the top here, so I remember my numbers. And again, as with anything in math and art, you have flexibility on the rules that you can create. I'm going to stick with clockwise. So if you think of a clock, the same direction that the hands go in, that's the way that we'll be drawing our spirals. But at the end of today, you can switch up the directions, you can switch up the angles, you can switch up the numbers. Again, you can create countless art pieces from any rules that you make for yourself. And we're going to be drawing line segments. Hopefully you're familiar with that math term. A line segment is simply just a line. It has a starting point and an end point. And we're going to limit on a square grid how long this line segment is. Okay, so you guys have given me 3 numbers, and those are going to dictate for me the length of my line segments. So very simply, if I pull up, let me actually erase this, I remember the numbers. If I pull up my square grid, which hopefully you have some grid paper lying around, if not, I'm sure your parents or your family or friends can help you get some of that. And there's so much grid paper you can print off online if you have a printer available to you. And the way that we're going to start this, and maybe I'll use different colors to help visualize this. I love colors, that's my artistic side again. Is simply isoclockwise. So I'm just going to choose a starting point. Let's say I start at this point here, just randomly. I'm going to go clockwise, which means I'm going to first go right by the amount that you told me. So we said 5 first. So I'm going to go, hopefully you can see me counting here, 1, 2, 3, 4, 5. And you can use a ruler. I just didn't want to add too much stuff on my whiteboard today. So you should definitely use a ruler or a straight edge in this case. We don't need to necessarily measure, just to create a straight line. And we went in the direction of right. So next, if you think about clockwise, we go right, then we are going to go, let me use a different color. We'll go down, then we will go left, and then we'll go back up, okay? So I'll try to use the colors as best as I can. You don't have to, and you can use any colors you want if you choose to use colors. So next we had a 7, if I remember correctly. So I'm going to use the red to go down by 7 units on my square grid here. So you might not be able to see that, but I'm just going to go down 7. 1, 2, 3, 4, 5, 6, 7. All right. Next, I'm going to go 8. You guys told me 8, so I'm going to go 8 left. If I open up my marker, that'll work better. So I'm going to go from where I ended off, 1, 2, 3, 4, 5, 6, 7, 8. And then I have to go up. So I'm going to use my black, but I have to go back to my 5 because we only use 3 numbers this time. If you use more numbers, you would just continue with the next number in your sequence. So I have to go 5 up. 1, 2, 3, 4, 5. Okay. And then I would just continue. I went up, so now I go back and I go left. So let's do that. But my next number is 7. So let's try that. 1, 2, 3, 4, 5, 6, 7. After I go right, I go down, and you would continue that pattern, and you can start to see spirals forming because of the directions that we used, right? Spirals out of straight lines, but that's all right. They're still spirals. So I'm now going to go down by 8. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to go right by 5. 1, 2, 3, 4, 5, and so on. Maybe let's do one more. Let's go. I said 5, so let's go 7. 1, 2, 3, 4, 5, 6, 7, and so on, right? I'll keep on going. Yeah, I'm glad you find this cool because can you imagine if I filled up this square grid with all these colors? It would form a really, really cool pattern, and that's what I want you to observe. So I challenge you after today's lesson to continue these spirals, and I promise you, depending on the sequences that you use, eventually you'll come across spiralaterals, I should say, where you end up back where you started. And so the sequence that you use will get you back to your starting point. So it almost seems like it's a loop that gets you back. And there are others that'll never take you back. And so they'll kind of keep on expanding down the page, and you only need just a super large grid paper to just continue it if you decide to. So that's one. It'll help you practice with your counting. I just chose any random numbers that you guys shared with me, but let's say I decided to use specific patterns. So let's say I decided to just go by ones, right? So my sequence is simply that, 1, 1, 1, 1, and so on. What happens? Let's observe. Well, I'm going to start, so let's say in this corner here, and I'm going to go right 1, down 1, I'm trying to remember my colors, left 1, up 1, and voila, there is a pattern, as I said, where you end up back where you started. Let's choose a different one. Let's go all the way up to 3. So instead of going 1, 1, 1, 1, we will go 1, 2, 3, then repeat it. Remember, these are just repetitive. 1, 2, 3, 1, 2, 3. Let's see if we end up back where we started. So I'm going to start with the green again. I'm going to start at this point, and I'm going to go right 1, down 2, because 2 is the next number in my sequence. Okay, and just so you know, in case you're not familiar with the word sequence, just another math term, it's just this list of numbers here in the order, and it's just, in my case, it's repeating. After 1, 2, 3, I'm just repeating that pattern. Then I have my blue because I'm going left by 3. Then I'm going to go up, back at 1, so up by 1. It's hard to tell the colors, I'm sorry. It's easier for me to see on my page. Then I go right by 2. Then I go down by 3. Then I go left back at 1. Let's see what this ends up looking like. 1. Then I go up by 2. Then I go right by 3. Yeah, you can absolutely do the same thing with Fibonacci numbers. Yeah, I love that. Choose any sequence you want, and if you had watched that previous lesson on Fibonacci sequences, there you go. You can definitely apply that. And then I can go, I believe I'm down at 1. No, I've just confused myself. But so on, right? And you would continue it with 1, 2, 3. And if you want to take this a step further and practice, let's say, your multiplication tables, the way that you would create your sequence, I'm going to put this to the side here, is this way. So we're going to take, let's say, the 2 times tables. So let's do 2 times 1 gives me my first number. You guys can help me fill that in. 2 times 2, 2 times 3. I'm going to write this out. You guys can share with me what these answers are. Okay. So let's see if anyone's sharing with me. I see a 2. Yeah, 2 times 1 is in fact 2, so that goes there. 2 times 2 is 4. We've practiced our times tables last week with Kevin, so we should know this. 6, 8, 10, and 12. But we don't want to have double digits here. And so the way that we're going to write our sequence is this way. So we're going to have a sequence that goes 2, 4, 6, 8. But instead of having double digit numbers, the way that we're going to approach this is add up the values of each digit, right? So I have a 1 and a 0. 1 plus 0 is just 1. So that's the next number in my sequence. Very good. Thank you for sharing, Robin. After, let's do the same thing with the 12 here. 1 plus 2 is 3. So that's going to be my next one. Can anyone help me with the next number here? So the way that you would obtain it is by thinking, what comes after 2 times 6? Well, I'm going to take 2 times 7. Think about what that product is, and then add the 2 digits in that number. Okay, 3 was right here. So what would be that next number? What is 2 times 7? Right, we have 2 times 7, if you remember from last week with practicing your multiplication tables. Very good, I see the number appearing. 2 times 7 is 14. 1 plus 4 is 5. What about the next number after that? Let's see if we eventually come to some repetition. So 2 times 8 is 16. 1 plus 6 is 7. I'm not seeing any repetition because the 7 is the first time it's appearing in this list. So then what would we have? 2 times 9, which is 18, and 1 plus 8 is 9. And what comes after that? 2 times 10. Think about 2 times 10. 2 times 10 gives me 20, and 2 plus 0 gives me 2, so I'm back at the start. Okay? So these would be the numbers that I use if I wanted to form a spirolateral using the multiples of 2. And I challenge you to do that after today and see what kind of spirolateral that forms after that. Perfect. All right. Hopefully you like that. I love it. I think it's going to form beautiful art pieces that it almost looks like, if I pull this back up, like abstract art, right? And then what you can do on top of that, once you form a spirolateral, is color in the shapes. It looks like rectangles and squares that'll form. And think about how beautiful that could be. And use any of your favorite colors to do that as well, right? So you can be an artist in your own house and frame them and have them on your walls. So there's one really cool one, and you can practice your multiples. If you're someone that needs to visualize a lot of what you learn in the math class, go ahead and do this. And so some of these spirolaterals might maybe stick in your mind, and this is the way that you really remember your multiplication tables. It's a beautiful way. Okay, so there's one. Now let's look at something else that we can do. And another way that we can practice our counting and our multiplication is, rather than forming spirolaterals, is just look at patterns that are formed in your hundreds chart. Okay? So, can we try with the multiples of 2, please? How about we do this, just because I don't want to spend all the time doing the spirolateral. I challenge you to create it on your own at home, and then tomorrow I'll have my completed multiples of 2 spirolateral, and that way you have to tune in tomorrow to see the completed form. How about we do that? And I'll write myself a note for that. Because remember, tomorrow we have part 2 of math and art. So let's look at this. So let's say, for example, I wanted to observe the patterns of the multiples of 2 in a hundreds chart. So let's see. So we identified a few of them already. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. So I'm just coloring the multiples of 2 in this chart and seeing if I observe a pattern. 2 times 5 is 10. Then we looked at 2 times 6, 2 times 7. What pattern are you observing here? What visual pattern are you seeing? I'm just going to fill in the next few. And I'm finding it very easy to do this because I've identified a pattern here. What pattern do you think that is? I'm going to stop there, but I could continue, of course. Ah, I see a beautiful comment pop up. I did forget 0. You're right. And so it doesn't look like there's a pattern that's necessarily being followed, but you're absolutely right. It's not that I forgot 0. It's that I started counting at 2 times 1. But there is a 0 in my hundreds chart, so I can absolutely remember and take into account 2 times 0, which is, of course, 0. Okay. So great. You're noticing that they're all even numbers. Absolutely, because we're multiplying by 2 each time. We're counting by 2. Great comment. You're skipping 1 square. Beautiful visual observation. I am skipping 1 square each time. It's going by 2, but also going in a line down. That's absolutely correct. They're all these vertical lines going down. That's right. There you go. Perfect. Yeah, that's exactly right. So there's the visual pattern in a hundreds chart of the multiples of 2, right? And it forms beautiful, in my case, blue lines. What if we tried it with, if I can erase this nicely, what if we tried it with, let's say, 7s? For some random reason, I'm going to choose 7, right? And again, for you students who are visual learners, which you can absolutely be a visual learner and be a math learner at the same time. You can definitely be an artist and be a mathematician at the same time. So don't think that those two have to be two very separate, even career choices one day. Because you can see how art already really helps you remember some of your number facts if it's not necessarily ingrained in your mind, right? Okay, so let's see. Let's do 7s. I'm just going to stick with a different color. Let's say green. So you guys are going to help me out. I'm not going to forget 0 this time. 0 times 7 is 0. 1 times 7, or 7 times 1 is 7. 7 times 2, I'm going to help myself out there. We did that earlier when we looked at 2 times 7. What about times 3? Okay, so I'm just going to continue it for us. Let's see if we can see a pattern form. Okay, let's see if there's anything cool. So I'm going to continue it for us. And for those of you that commented earlier, great, you're showing me 3 times 7, that you're just skipping by 2s when it comes to multiples of 2s. That's exactly right. So if you don't necessarily have your 7 times tables ready to go to help you out, you can always find it out by just counting the next 7 numbers. So if I go back to 28, I skip 7 numbers. 1, I go to the next row. 2, 3, 4, 5, 6, and I color in the 7th one. I'll do that again. 1, 2, 3, 4. Next row, 5, 6, 7. Right? If I do that again, I'll get to 49. Okay? So I am counting by 7. Good. Yeah, it's not that easy to observe a pattern just yet, right? I'm definitely counting every 7th one. But what do you think? I'm kind of seeing something form. What do you think? Let's keep counting. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to take a guess here. I kind of see a pattern forming. I'm going to take a guess that 84 is also 1, that 77 is also 1. Why do you think that's the case? Are you possibly seeing what I'm seeing, which are some of these diagonal lines? Look at that. Okay, and they're not perfect diagonal lines, right? I'm not going 0, 11, 22, and so on. Those would actually be, coincidentally, my 11s times tables. Yeah, so I see you guys are trying to explain in the comments. I don't even know how I would explain it just yet, but 3 lines going diagonally down, good. The way that I counted it in my mind was when I went from 63 to 84, I went 2 down, 1 right. From 56 to 77, 2 down, 1 right. From 28, 2 down, 1 right, I get to 49. Yeah, stripes, I think we see that. Oh, did I skip 70? You're absolutely right, I did. 7 times 10, right? And so eventually we would start to see some diagonal lines forming from there, right? So that's really cool too. And what you can do is ask your parent or someone that can help you out to give you many hundreds charts, unless you want to just stick with one, and use a different color for the different times tables, and you can visually see how they form patterns just like that, right? That they're all related numbers in many more ways than just the fact that you're counting by those multiples, if that made any sense. So there is that. You can see it in the hundreds chart. Let's also see how this can fit around a circle. And if any of you guys have ever heard of string art, this is one of my favorite things because you can really make this very hands-on. And again, this would require a lot of assistance from a parent or an adult in your household, but you can really make beautiful art by looking at multiples as well. And I see you guys are seeing 91. Perfect. I was waiting for someone to tell me that. After 70, if I go 2 down, 1 right, there is also 91. Perfect, right? Very good. So let's remove this and actually look at some patterns on the circle. So I'm going to pull one up here and see how we can look at maybe the multiples of, let's say 5. So I have a circle prepared here. I'll explain to you in just a second how I formed this. We don't need those numbers just yet. Look at that. Perfectly fits in the screen. Okay. Great. I love the comments that are coming in. Sorry, I just love reading how you guys are visually seeing these patterns and observing already how these different numbers can be popping up, even if you don't have necessarily your sevens times tables memorized up until a really high number beyond 100. So let's see. Let's see if I wanted to look at the multiples of 5, right? So you guys are going to help me out here. We're going to connect. I don't have all the numbers filled in, but you can understand here that I have a bunch of dots here. I decided to go up until 35, and I can take the time to number these all the way around, okay? And what I'm going to do, and you'll have this available to you afterwards, is I'm going to connect all the multiples of 5 and see what pattern they visually create for me. And the way that we're going to do this together, let's hope I didn't mess anything up here, is you guys are going to help me count by 5s. So you can go ahead and start sharing that while I just fill this out for us. Look at that. I didn't mess any number up. I surprised myself. All right, so I just counted all the dots all around that I have prepared. Earlier, what I did was I just traced over a circle that had 35 or 36 points in this case. So I start from 0 and I go all the way to 35. And we'll see what happens after that. Okay, perfect. So let's see. So I'm going to start at 0. And I don't have a straight edge with me or a ruler, so I'm just going to do my very best here. 0 times 5 is 0. 1 times 5 is 5. 2 times 5 is 10. Look at that, right? I'm just connecting them with straight lines here. 3 times 5 is 15. And I'm just going to turn it to help me out here. Then we have 20, 25, 30, 35. Beautiful. Thank you for that. 20, 25. Let's see, 30. Wish me luck with this one. 25 to 30. Then I go to 35, and we don't have to stop there. So you can already start to see that I've formed a beautiful shape, but I'm going to continue it. So let's go beyond that, right? What happens after 35? Let's see if anyone helped me out there, right? I would go to 40. I don't have a 40 on this initial circle, so I'm going to start counting 5 ahead, which makes me end up at the 4. So let's double check that. 1, 2, 3, 4, 5. So I'm going to go to the 4, right? Then I need to go 5 more ahead. 1, 2, 3, 4, 5. So I get to the 9. And you can start to see that I just go to the number that comes before the dot that I had already used. So I go to the 14. I'm just turning my page to really help me out. I go to the 19. Then I go to the 24. Again, I'm doing this without a straight edge because today I'm confident in my straight lines, but I don't recommend it. I recommend using a straight edge here. And I'd go to 34, and then I just keep on going, and you'll start to see a beautiful shape form. And what I was saying before, if you have a cousin, a sibling that has done this maybe using what's considered string art, and so they attach a string to each of these points, it creates such a beautiful piece of artwork that just hanging on the walls would just look absolutely fantastic, especially if you have colored string that you use each time, right? Yeah, it does look like a hexagon, right? Very good. Great observations. Beautiful. Love it. Right? You guys can already start to see. So it's yet another way to see how patterns can be formed just from something as basic as counting, right? For some of us, when we count, we think they might eventually get boring, right? But when we start to look at the patterns visually that this creates, we see again how art can really bring another level of beauty to the things that we work with in math, which is just my absolute favorite. Okay? So let's see if we can look at a different pattern. Let's say we look at doubles, right? What if instead of counting by 5s, which is what we did here, we looked at the multiples of 5, we just double up our numbers. So I'm going to pull up a different circle that I have here. I'll put this to the side, right? And so in this case, I kind of did it upside down, and there's a reason for that. I have my 36 dots here. I'm starting at 1, right? And so this 36 can be both a 0 and a 36. It's my beginning and my end. And then I go 1, 2, 3, 4, and so on. So I'm not going to fill it in this time, but with my blue, I'm going to start at 1, double it. We've talked about doubling in previous schoolhouse lessons. What does doubling mean? Oh yeah, very good comment that came up before. Numbers will always end in a 5 or 0 when we look at multiples of 5. Beautiful. Great observation. What does doubling mean? And if you can't really help me define that, no problem. What is 1 doubled? Let's see if that comment comes up. And maybe I'll help you out. I'll get to 2 if I doubled 1. Then if I go to 2 and I double it, I'm actually going to get to 4. So if you kind of imagine these as counted, as numbered, I should say, there would be a 3 here and a 4 here. So I'd actually go from 2 to the 4. Okay? Yeah, multiplying times 2. Beautiful. Very good. All right. Then if I had the 3 here and I doubled it, right, what would I get to? I think someone helped me out. That would be the 6. So let me help myself out here. So I'd get to the 6. And then maybe let's do one more. If I started at the 4 and I doubled it, I would get to the 8, which would be here, and so on. So here's another challenge I'm going to leave with you. And this, and you can complete it tonight and then bring it with you to tomorrow's lesson where I'll have mine completed. And we'll talk about the shape that this forms. It's actually a very famous shape in the math world. So I challenge you to complete this again. We're looking at doubling. And in the packet that will be shared with you today, just after this lesson, you'll have this template that you can fill out, and we'll observe what happens here. And another observation that I ideally want you to see, if you can't name the shape, which is perfectly acceptable, is what else is forming when we have these straight lines? Do you start to see that maybe they deceive you in almost looking like they're curved? And I kind of started to see that a little bit here, right, in the previous in the previous circle that I used. So I had straight lines, but it almost looked like they formed curves before. That's another really cool thing that we learn in math and art, is we can use straight lines to deceive us into thinking that there are actually curved forms, curves formed. All right. So there's one, and I'll leave you with another challenge in the packet as well. And I am going to end off by also helping you guys form stars. So let's say, for example, I take a bunch of these dots and I've numbered them 1 to 7. I just decided to have 7 dots here. And I challenge you to connect every third dot. So let's see what happens here, right? So if I start at 1, where would I get to next? Well, every third means I go to the 4. Okay. Then every third means where do I go to next? Well, I'm going to go to the 7. Again, a straight edge would be most helpful here. Then if it's hard for you to see where we're going to end up after we go around the circle, you can just count by the 3, right? So similarly here we went 1, 2, 3, and that's where we attached it. 1, 2, 3. We can attach it at the third one again, the third dot. 1, 2, 3. So I'm going to go from the 7 to the 3. It does make a star, yeah. 1, 2, 3. And we're going to keep on going until we get back to where we started. From the 6, let's go 1, 2, 3. And then we're going to go 1, 2, 3. And then guess where I end up again. So 1, 2, 3. I go back to where I started. So how can you explain what type of star this is? What would you say? How many points does it have, if I help you out there? How many points does the star have? Well, maybe what you can observe is it has the same number of points as the dots I started with initially, right? So it's a 7-pointed star. And if I use straight lines and I made sure that these were all even, it would be a really perfect 7-pointed star. And to end off for today, and don't forget that we have part 2 of this tomorrow, so you can bring your completed pieces of work. Oh, you told your mom that. Very good. So you knew already. Very nice. You can bring your completed pieces of work and compare them to mine as well tomorrow. But I challenge you to color in this star once you create it and see how many colors you need given the condition that any sides that are touching each other can't be the same color. Okay, so let me repeat that one more time. So you're going to use as little colors as possible. That's your challenge, okay, to make sure that any sides or any spaces that share an edge, so for example, this triangle here and this shape here, these two share a side. There are 2 spaces right next to each other, so they cannot be the same color. So my challenge to you, which is another famous theorem in math, is to find out what's the least number of colors I will need to color in the 7-pointed star. Okay? So go ahead and do that. And the other challenge I'll leave you with is starting from point 1, is it possible to trace along all of the lines in this shape without tracing over them twice and get back to where you started? Okay? Again, all of that will be available in the worksheets right after today. I challenge you to work on that tonight, but I also challenge you to maybe take a walk tonight with your family or some friends, whatever is allowed in your community, whatever you're capable of doing tonight, and see how in the world that surrounds you, you can start to see how math and art coexist together, okay? And take some of the activities even that we worked on today and make some alterations for yourself. I'll leave some additional extension challenges for you. And color them in and maybe hand them out to your friends and family members as pieces of art that all came from just some very basic math concepts that we know. So I'm going to end it off there for today. I hope you practiced with this. I hope you had a little bit of fun already. And tomorrow, what I want to focus on after reviewing some of these activities from today are 3D objects and how there's a lot of art and math connections between some 3D geometric objects and figures that you would have already seen. I'm going to leave it there for today. Thank you all for joining me. I apologize once again for the technical issues in the beginning. I thank you all for sticking with me today. I'll see you next time. Bye-bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.